All right, Unit 2, Chapter 2, Section 1, Scientific Notation. We're going to talk about what it is, essentially, maybe how to convert back and forth from like a regular number to the number written in this certain notation, and then doing some operations with numbers in this notation. Scientific notation basically looks like this, where you use a number and then you multiply it by 10, and it's always a 10 as like a base over here with a certain power. And we use this kind of thing when you're talking about numbers that are really big and have they have like a lot of digits to it, and or we could actually use scientific notation when the number is really small, as in a decimal that goes out a lot of decimal places. So in order to avoid writing a lot of digits, whether there's a decimal or not, we like to use scientific notation. So here's how it sort of works, I guess. This number right here is a really big number, because if you're going to multiply by 10 to the 8th power, that's a really big number. Remember, this is essentially a 1 with 8 zeros. It's like 100 million or something. So anyway, to really cut to the chase and get to the bottom line, or one of the bottom lines, what really happens here is if you're multiplying it by 10 to a power, if it's a positive power, 8, you're going to take the decimal place and move it 8 places to the right. So let me grab my pen tool. So you're going to move this decimal place 1, 2, 3, 4, 5, 6, 7, 8, and it looks like you would need 3 placeholder zeros here, here, and here. And so when you write out this number the normal way, it's going to look like this, which looks like 237,008,000. Okay? And, I guess we've already sort of discussed moving it one way, but let's do now some official examples. Example number 1, write each number in scientific notation. And something, I'll throw this out here right away. I'll try to follow up on it and repeat this when it pops up, but true scientific notation, I guess there's more to the story than just it's a number that's being multiplied by 10 to a certain power. The full definition has to touch on the fact that this number over here has got to be between 1 and 10. All right? And, I say the word between loosely. I guess I don't need to go into great detail there, but really, there's a reason this number here is 2.37008, and it's not 23.7008 or 230. Like, the decimal point can't be here. The decimal point can't be here. The decimal point can't be here. It's got to be there, 2.37008, making it between 1 and 10. So the leading number out here has got to be between 1 and 10. So if we wanted to write this in scientific notation, the decimal point for the number, which is now here, but it's got to go there. Okay? So it's going to be essentially, maybe I'll write it out this way for now, 6.95 times 10 to the what power. So that's what you got to figure out essentially, 6.95 times 10 to the what power gets you this? Well, you'd be moving the decimal point to the right. 1, 2, 3, 4, 5, 6, 7, 8. So this large number would be 6 point, here, I don't know, 6.95 times 10 to the 8th power, which makes sense because when it's a positive power in your scientific notation, that usually represents a very, very, very large number, like 695 million meters. Going the other way, well, actually not, sorry. Probably shouldn't have said it quite like that. I guess saying a really, really small number instead. So if this is scientific notation, then the decimal point won't be there. It won't be there because remember, if it was 0.239 in my, that'd be too small. It's got to be between 1 and 10. And 23.9 would be too big. So the decimal point's got to go right there, which would make it 2.39. Remember, 2.39 is between 1 and 10. And so essentially we have to figure out what's the power on the 10 that would take the decimal point back to here, to the left. 1, 2, 3, 4, 5, 6, 7. You know, so we've been moving it 8 places to the left, which means we're going to use a negative power. If it's a negative power, sorry, I'm like a little OCD or whatever. So if it's a negative power, it moves to the left 8 places. And just like I mentioned how a positive power would pretty much represent a very, very large number, an abnormally large number, a negative power represents an abnormally small number. Like, look at this. I don't even know what to call this. 10/100,000th of a calorie? I don't even know. I mean, like, this is what? The tenths, hundredths? Or wait, tenths? I'm not even going to do it. I mean, this is just a really, like, look at this. 0.000000239. That's a very small number. And so a negative power represents a really, really small number. Now we're kind of going the other way, where the decimal point is here at first, and a -6 power, you know, to make it into like just a normal number, we're going to move it to where? To the left or right? To the left. 1, 2, 3, 4, 5, 6. Decimal point ends at, whoa, what the heck is going on there? Like a active board glitch or something. Anyway, let's write it over here. So if you start off with like 1.0 and move the decimal place 1, 2, 3, 4, 5, 6 places to the left because of the whole -6, we'd have a 0, 0, 0. So we'd have like 5 filler zeros. Right? So just to kind of, I'll just use my, so it was here and it went 1, 2, 3, 4, 5, 6. So the decimal point ended up right there. And so we had these 5 filler zeros right there. And again, just if it's times 10 to a positive power, it means you're going to be moving the decimal point to the right 5 places. So it's going to go 1, 2, 3, 4, 5, and it looks like that's going to mean 2 filler zeros so that the decimal point ends up essentially right here. Okay? So that covers you know, converting from a regular number. So I guess to kind of summarize, I mean, this video is not going to be that long anyway, so we can summarize. If you're changing from a regular number to scientific notation, you just have to think about what power would it take to take a decimal point from there to here, and again, like if it's a really, really large number, you know the exponent should be positive, and same thing, what would be the power that would take the decimal point from here, 2.39, all the way over here to the left? And again, you got to realize that a really, really, really small number like 0.0000000239 would have a negative power. This direction's easier because you just kind of take the decimal point from here and then go to the left 6 places to make it into a real, regular, normal number. Same thing here. From scientific notation to a regular number, you just look at the power, and if it's positive, you go to the right. 1, 2, 3, 4, 5. All right, now changing gears, because what we're about to do is operations involving scientific notation. It's going to help a lot to remember from last chapter these basic rules of exponents. So I hope you remember this. We just took a test on it. Probably last class we were together. So how do we do 10 to the 5th times 10 to the 2nd? When it's the same base, and you're multiplying the bases together and they each have a power, you add the powers, right? So this one would be 10 to the 9th. What happens when you're dividing the same base, like 10 to some power divided by 10 to a power, it's the same base? You subtract the powers, right? Right? Of course you do. Well, this is going to come into play now. So here's the example, right? Simplify. And notice in the directions, we want to keep our answer in scientific notation form, which is going to mean a number between 1 and 10 times 10 to a power. So that's going to be what our final answer needs to look like. Anyway, here we go. What we're supposed to be doing is multiplying this number that's in scientific notation times this number that's in scientific notation. How are we going to do this? It's actually going to be quite easy, and it's actually going to be very, 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 very comparable with something we did last chapter. We just took a test on it. So I want you to realize that this is very comparable with something like this. All right? Again, the 10 and the 10 here are matching bases. You could treat it like x. Like how would you do this? 5x to the 7th times 1x to the 8th. Wouldn't you do the 5 times the 1 to get 5? And then wouldn't you do x to the 7th times x to the 8th and just add the powers? Yeah. So, look, again, sorry to repeat myself again, but, the 5 times the 1 you can just do, and then 10 to this power times 10 to that power will be 10 to that power when you add the powers together. So, in conclusion, to multiply scientific notation numbers together, do the numbers out in front, multiplied together, and then just add the powers on the tens. Same thing over here. This is kind of like when you're doing like 4 times 10 to the 5th times 2 times 10 to the negative 9th. Again, you could just treat it like, this 10 was a base of x. It's like the same thing. So what we're going to do is essentially 4 times 2 to get 8. And then we're going to take this part times that part, and we're going to add the powers. What's 5 plus negative 9? Negative 4. So the final answer here is 8 times 10 to the negative 4th. Now, I want to take a breath really quick before we move on. I want to point something out. It's not going to be a big deal at the end of the day, but I want to ask you, is this and this, are these two final answers acceptable final answers? In other words, is this in true scientific notation? Is this number in true scientific notation? Well, I think the deciding factor would be, is this an acceptable leading number out here? Is this between 1 and 10? Yeah. And is this 8 an acceptable leading number that's between 1 and 10? Yeah, This is like, 8.0. This is 5.0. They're good numbers for scientific notation. And so here's like an inside scoop. I think they're all going to be like this. They're all going to be like, there's not going to be any curveballs at the end, which I think you'll understand when I said, what if you were doing 5 here and a 6 here? What's 5 times 6? You would have had a 30 as your leading number. And guess what? You can't have a number like 30 and be able to call it true scientific notation. So if I threw a problem like that at you, you wouldn't be done. You'd have to adjust your number in order to make like the 30 into 3.0, and you would have to like adjust the power. And anyway, I mean, same thing over here. If it was 4 times like 6, instead of 4 times 2, you'd have like 4 times 6 would have been 24, which is not a good number if for true scientific notation. So you'd have to like adjust it a little bit. But I guess in case your head is spinning right now, I don't think you'll have to do any of that ever, in this class. But I just want you to remember that 8 is good for scientific notation, so you're off the hook. That makes things easier. And same with 5. Hey, nothing new here. Remember, we can just do 7 times 1, right, which is just going to be 7, and we can do this base and a power times base, and just add the powers. So boom. And is this an acceptable number in scientific notation? Yeah, 7 is between. So again, it's like, thank goodness this was just a 1 and not a 2 or a 5 or a 8 or a 9. You know what I mean? Because you're done. And whew, okay. All right, do this one. Right, when we're multiplying these numbers together, you can do the 3 times the 3 to get 9. And then when you're doing this times this, matching base, you can just add the powers. What do you get when you add the powers? What's negative 7 plus negative 13? Negative 20. Always double check on a calculator if need be. All right, look, just one more slight change of gears. I mean, not really. We're just dividing now. So I want you to remember, imagine this was like a fraction, where you could say these tens are just like m's. I mean, look, why don't I actually call an audible here and just like literally keep it 10, I mean, now it's literally the same thing. And like, what would you do? Like what we did in the last chapter. Wouldn't you've just divided these numbers and then taken the powers that were on the same bases and subtracted them? So when you're dividing numbers in scientific notation, just divide the leading numbers as is, and then take the powers on the tens and do the first one minus the second one. So 3 divided by 1 is 3, and then 20 minus 6 is 14. That's how it's done. And again, 3 divided by 1, that ends up being super nice, and it's true, scientific notation, because 3 is between 1 and 10. Same thing here, man. We're just going to do 4 divided by 2, which is 2. And we're going to do this power minus that power. Ooh, be very careful here. Be very careful. 8 minus a negative 5. 8 minus a negative 5. There's a double minus there. So just be sure, because this is really the same as 8 plus 5 when you do minus 5, and you get 13. Double check on your calculator. And that's it, folks.